Alright, ladies and gentlemen, today you're going to use your math paper, and it's lesson 5-2. Use properties to multiply by 3. We're going to start on page 167. We're going to start with how are they the same and how are they different? How are they the same and how are they different? Hopefully you notice it's the same type of food. So that's how they're same. One of the ways. And look, this has 2 rows of 4. This has 3 rows of 4. So if I circle, I can have two rows of 4. This one just has an extra row of 4. So let's go ahead and flip the page. Let's learn what we need to learn today. Yasmin set up 3 rows of 9 chairs for the talent show. So look, she drew an array. 3 rows, so 1, 2, 3. And there should be 9 chairs in each one. 1, 2, 3, 4, 5, 6, 7, 8, 9, which there is. How can you find the total number of chairs? Well, that means we have to find the area of all of the squares. 3 times 9 equals blank. You can represent the problem with an array and a multiplication equation. You can decompose, remember, decompose means to break apart, 3 into 2 and 1. So instead of having your 3 rows, we can have 2 rows, which gives us 2 times 9, and then 1 row, which gives us 1 times 9. Find the product of the 2 facts and the 1 fact, and then add the products together. So this is a partial product, and this is a partial product, and when we compose them, put them together, we get 27. As you decompose 3's facts into 2's facts and 1's facts, then you can find the sum of the products. So let's read the bottom ones to work together. James places 7 cans each on 3 shelves in the kitchen pantry. How can you compose 3 and find the different number of cans? A total number of cans, not different. It's going to be the same thing. So let's read that again. We always read it twice. James places 7 cans each on 3 shelves in the kitchen pantry. So we got to make sense of this. So when I think of a shelf, now I'm not an artist, but I draw a shelf, and there's 1, 2, and 3. There's 3 shelves. Alright, and there's 7 cans on each shelf. So if I do 1, 2, 3, 4, 5, 6, 7. There's 7 on one shelf. 1, 2, 3, 4, 5, 6, 7. 7 on another shelf. 1, 2, 3, 4, 5, 6, 7. 7 on another shelf. Now, so right now that's my thinking. How can you decompose 3 to find a total number of cans? Well, we can say, well, this one's a roll of 7, and this one's a roll of 7. So these 2 would make 2 times 7. If I just did these 2 rows. If I did this row, it could be 1 times 7, because it's just 1 row. 2 times 7, with my 2 facts, I know I can double my 7, which get 14. And 1 times 7 equals 7. So these are my 2 partial products, because they're partial of the total, which is called a product in multiplication. And when you add these 2 together, you're going to get 21. We decomposed, and then we got the answer. So there's 21 cans is what my answer would be. Moving on over, now we're going to go to page 169. 169. You've got 3 times 4. So we can do this multiple ways. If you need your graphing paper, you can go get your graphing paper, and you can do 3 rows of 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. We can do that, and we can go, okay, 4, 6, 7, 8, 9. What? 4, 5, 6, 7, 8. I knew that wasn't a multiple of 4, so I had to change it. 9, 10, 11, 12. So each time I went up by 4 if I was counting, so my answer would be 12. We could count this way too, in 3, 6, 9, 12. Alright, so that's one way that we can do it. We can do, oh, look at the next one. 2 is giving us another balanced equation, remember? So 6 times 3. Oh, but wait, look. 3, 3. So that means that this other number has to be 6 because it has to be balanced. So they used the invert. They inverted the factors, didn't they? Because that is called commutative property. We've learned about that commutative property. Alright, now this one's a balanced equation. On this side we've got 24, so we need to make this side 24. So remember how we did that? We can use our fact families and say, okay, well, 24 divided by 3 equals, and that's going to give me my other number. So I can go back over here to my array, and I know I'm going to have to use 24. So 24 divided by 3 equals. So I need to put them into groups of 3. So 1, 2, 3. I've used 3. 4, 5, 6. I've used 6. 7, 8, 9. I've used 9. 10, 11, 12. I've used 12. 13, 14, 15. I've used 15. 16, 17, 18. I've used 18. 19, 20, 21. I've used 21. 22, 23, 24. I've used 24. So now I know that each one of them's got 3, so I need to count 1, 2, 3, 4, 5, 6, 7, 8. So my answer would be 8. Now that was one strategy that we could have used. Now could we have, we could have broke it down the way that they were talking to us about breaking it down. But I think this would have been the best strategy to have got to the answer, is by drawing the array if you didn't know what 3 times blank equal 24. Let's go to the next one. We've got 3 times blank equals 6. That's a smaller number, isn't it? So if I go 3, 6, how many 3's do I have to use? 1, 2. So I know 3 times 2 is 6, because if I double my 3, then I get to 6. Oh, we've got commutative property again. We've got 10 on this side, so we've got 10 on this side. Remember, we have to have it balanced. So 3 and 3. Oh, here's our 0 property. Look at this. We got a 0, so anything times 0 is 0. 3 times blank equals 3. Oh, look at this. 3 and 3. So the only thing we can do is multiply times 1, because 1 is multiplied by another number is the other number. Alright, now we've got 3 times 9. This could be a one that we could break down. We can do, okay, what is 2 times 9? And then we're going to add together 1 times 9 to get my answer. So 2 times 9 is 18, because we double our 9. 18 plus 1 times 9 is itself, which is 9. So when I add those two together, I get 27. Look at how many different strategies we have to answer multiplication. Wyatt saves $5 a week. How much money will he have after 3 weeks? So we read it one time. Now we're going to have to read it again. Wyatt saves $5 a week. How much money will he have after 3 weeks? So let's make us a table here to make this is making sense. So this is weeks and this is money. So if he has 1 week and he can save $5 each week, that means he would have $5, right? So in 2 weeks, we would double that, so he would have $10. In 3 weeks, he would get $5 more, so he'd have $15. Now, thinking of our equation that we can make, equation, E-Q-U-A-T-I-O-N, equation. Our equation would be from this 3, because it's 3 weeks, times $5 equals how much money they would have. So equals $15. So now we have to write our sentence. How much money will he have after 3 weeks? After 3 weeks, he would have $15. Period. Alright, on the next one. Otto has 7 packs of 3 erasers. How many erasers does Otto have in all? So, Otto has 7 packs of 3 erasers. So let's make it make sense. This is us making, okay. So Otto has 7 packs of 3 erasers. So if he had 1 pack, so I'm going to put packs up here. I'm going to put erasers over here. So if he had 1 pack, he has 3. He has 2 packs, he has 6. He has 3 packs, he's going to have 9. So I can already see the pattern that I'm getting. So that means that I need to do the equation, E-Q-U-A-T-I-O-N, is going to be 7 times 3 equals. Now, if you know what 7 times 3 is, then you can just go ahead and write it. If you don't, we have an array that we can build. We have skip counting that we can do. We can do 3 7s or 7 3s, but I would rather do 3 7s. We could also decompose it to 7 times 2 plus 7 times 1. And since that's the strategy that they're showing us today, that's what we're going to use. So we can decompose it to 7 times 2 plus 7 times 1. Now, Ms. Haycraft puts it in parentheses. That's what those bars are. It's because I want you to know that we need to do that before we add. Okay? So, and it's another step in algebra that they will have you to use. So 7 times 2 is 14 because we double a 7, plus 7 times 1 is 7. So then when we add those two together, we're going to get 21. These are partial products because the answer to a multiplication problem is called a product. 21. Now we need our sentence. How many erasers does Otto have in all? So Otto has 21, and we have to write down the erasers because that's the unit on which we are doing. So we need to know what the 21 is. On question 11, Caitlin walks dogs 3 times a day. She walks 6 days in a row. How many walks does she take during those 6 days? So let's read this again. Caitlin walks dogs 3 times a day. Wow, so she does it 3 times a day. She walks 6 days. All right, so let's build this. So, days and walks. So, if she walked 1 day, she would walk 3 times, right? If she walked 2 days, then she would have walked 6 times. If she walked 3 days, she would have walked 9 times. I'm seeing the pattern. Are you seeing the pattern? They're going up by 3 each time, and we know that's multiplication because it's repeated addition. So I can write my equation, E-Q-A-T-I-O-N, equation, and it's 3 times 6 days equals. So what is 3 times 6? You can solve it multiple ways. So I'm going to break it down. I'm going to say 2 times 6 plus 1 times 6. So I've got 12 plus 6 equals 18. So my answer would be 18. Now I just have to write down the answer. How many walks does she take during those 6 days? So she takes 18 walks in 6 days, period. Alright, so that's page 169. Flip it over. And we've got the back. Let's readjust our camera here. This is page 170. Which is equal to 3 times 9? Now remember, we're decomposing, and they don't put the parentheses around their numbers like Miss Haycraft does. So I'm going to go through and put my parentheses, and I want you to do that too. The parentheses do not include the plus sign. You have to get this partial sum and then add it to this partial sum. Okay, so this one, they kept 9 the same. Did they decompose 3 with the other 2 numbers? No, because that would have been 9, so that's wrong. Okay, they didn't keep 9 the same. Well, that's just a hot mess. Because they didn't keep 9 the same, and they didn't decompose 3. Or keep 3 the same, either one. Alright, they kept 9 the same. Did they decompose 3 with 1 and 4? If I put 1 and 4 together, does it give me 3? It does not. Alright, they kept 9 the same. Did they break down 3? They did, because 2 plus 1 is 3. So this is the only one that could be correct. Moving on to 13. Which is equal to 3 times 6? Now remember, put those parentheses in there. Drives me nuts that they don't do that. Now, in our orders of operations, you had to multiply before you add anyway in PEMDAS. P-E-M-D-A-S, PEMDAS. You've got to do parentheses first, then exponents, which we don't touch on yet. Then you multiply and divide, and then you add and subtract. So even without the parentheses, you would have to multiply first and then add. Alright, so let's see what they did. They kept the 6 the same. Did they break down the 3? Can you add these 2 numbers back together and get to 3? You can. Alright, did they keep 6 the same? No. They kept 6 the same. Did they break down 3? No, because if I add those 2 together, I get 4. They didn't keep 6 the same. And they didn't break it down. So the only one that could be is A. On 14, Doris played in 3 basketball games. The number of baskets she made is shown. If all of her baskets were 2-pointers, how many points did she score per game? What if they were all 3-pointers? Complete the table. All right, so I read it once, but I'm going to read it again to make it understand. Doris played in 3 basketball games. Numbers of baskets, 2-pointers, 3-pointers. Okay, so We just know that she played in 3 basketball games. That's the reason there's 3 rows. The number of baskets she made is shown. So in the first one she made this, second one, and then the third one. Number of baskets. If all her baskets were 2-pointers, how many points did she score per game? So, if every one of them was 2 points per game and she had 3 baskets, it would be this. If they were 2-pointers and she made this many baskets, it would be this equation. So 2 times 3 is 6, and 2 times 5 is 10. So, we're not done though. What if they were all 3-pointers? Complete the table. Okay, so we've got to do 3 times how many baskets now for each one of these. So 3 times 4, 3 times 3, and 3 times 5. Now, I can count by 5s on this one, so I know it's 15. Count by 5s. 5, 10, 15. On my 3s, some of you all are really good at counting by your 3s, so you can count by 3s on that. You may want to add 3 or 3, or you may want to use your graph paper. And if you've used graph paper on this lesson, I want you to staple it to your work plan when you turn it in too. So 3 times 3 I know is 9. And then 3 times 4, well, that means it's just 3 more than my 3 times 3, which is 12. All right, one more down here. Extend your thinking. No idea how to say this word, so I'm going to call them M. M decomposes. Remember, decomposes means to break apart. M decomposes 3 to find the product. Now I know what a product is. It's the answer to a multiplication problem of 3 times 8 is 24. Now M needs to find the product of 8 times 3. He says he can decompose the fact into 8 times 2 and add 8. How can Mufasa use a different strategy to solve? Oh wow, there's so many different strategies to solve. And honestly, guys, if I showed you, then I'm going to be forcing you into using my strategy, because you could build an array. You could do repeated addition. I mean, you could do so many different things because we've worked with so many different things. So I'm just going to let you solve on this. All right? When you get this solved, I want you to make sure to go back, and you're going to start, because you started on page 167. Make sure you can see the numbers. Page 167 and shaking. 167, and then 168 is the back of it, 169, and 170. And you're going to tear that out. And any of your graph paper that you used, you're going to put all this together, and then you're going to use the stapler. I'm going to have a stapler, and you're going to staple it to the back of your work plan, because this is going to be turned in when you turn in the work plan to me.